Welcome to this presentation. My name is Mark Scythian. The date today is October 14, 2025. This presentation will cover rifle comparative analysis AR-15 versus AK-47. So this analysis will find the conclusions and the pros and cons of both rifles. If you stay with me throughout the duration of this presentation, you will see the engineering physics analysis, which prove the pros and the cons. So the first step is we have to convert the muzzle velocity into its meters per second metric values, then the barrel length D into its meters length, and then the firing time T. This is the ratio between the barrel length and the muzzle velocity. And next we calculate the mass of the AR-15 round in kilograms. So we have to convert 55 grains into the milligrams value. So there's 64.8 milligrams per grain. Then we convert the milligrams to grams and then the grams to kilograms. So for both rifles, we will solve for the force accelerating the bullet, ballistic power, kinetic energy, bullet impact pressure, smokeless gunpowder charge per round, and bullet gravity drop per 100 feet for both rifles. So we have to convert the specifications for both rifles into the metric values in order to apply the engineering physics and the scientific method. So then calculate the force accelerating the AR-15 bullet. So we can use force as mass times acceleration, which is Newton's second law of motion. But first we have to solve for the acceleration of the AR-15 round. So that is the muzzle velocity V divided into the firing time T. So we calculate an acceleration for the AR-15's 55 grain round equal to 2,041,518 meters per second squared. We then multiply that times the bullet's mass. We calculate 7276 newtons force accelerating the AR-15's round, and then there are 4.45 newtons force per 1 pound of force. So we can divide 7276 into 4.45. We calculate 1635 pounds force accelerating the AR-15 round. So we'll go ahead and convert this back into the Newton's force value for future calculations such as the ballistic power. So next we can calculate the ballistic power P measured in watts, and this is force times distance divided by time. So that is the force in newtons accelerating the AR-15's round times D, the barrel length, divided into T, the firing time. So we then yield a product of Newton meters. So 1 Newton meter is a joule, and 1 joule per second is 1 watt. So we can divide the Newton meters product calculation into the firing time. So we calculate an approximate ballistic power for the AR-15 equal to 6.7 megawatts. Next we move on to calculate the kinetic energy. So the equation for kinetic energy is 1/2 mass times velocity squared. So we have to use the metric value units. So 1/2 times the bullet mass measured in kilograms times the muzzle velocity of the round in meters per second, then quantity squared. So this will calculate the joules of kinetic energy for the AR-15. And then we know that 1.36 joules is equal to 1 foot-pound of kinetic energy. So we can divide 1491 joules into 1.36, and we calculate 1096 foot-pounds of kinetic energy for the AR-15 223 55 grain round. Next, we have to focus on the 223's caliber, or its diameter. The bullet diameter is the caliber. So when it's written just 223 or 223 caliber, that implies 0.223 inches diameter or caliber. So this value is used to calculate the bullet impact pressure, so we can solve for the radius of the diameter. So we divide the inches bullet diameter to 0.223 into 2 to get the radius. We square the radius, multiply it times pi, and this calculates the cross-sectional area of the AR-15 round. And then pressure is force divided by area. So in this case, pounds force, 1635 pounds force applied on the AR-15 round divided into its cross-sectional area. So this is relevant during impact because the force accelerating the bullet is equal and opposite upon impact. That's Newton's third law of motion. So right before there is impression or penetration, there's an instantaneous equal and opposite force. So that's then applied across the cross-sectional area. And this will translate to 41,923 pounds per square inch of bullet impact pressure for the AR-15. So we'll write that in on the left side there. Next, we can calculate the smokeless gunpowder charge per round for the AR-15. So what's relevant is the average potential energy for smokeless gunpowder, which is 3504 joules per gram. But we must account for the rifle barrel friction loss as the round travels through the bore. And so when we're dealing with rifles, there's approximately a 25 feet per second loss per every inch of barrel length. So we have to calculate the actual potential energy in smokeless gunpowder needed to overcome that friction and then result in the rated velocity of 30,000 feet per second. So to compensate, we can multiply the rifle barrel inch length, 16 times 25, and add this to the muzzle velocity rating. So this will yield the gross muzzle velocity rating. After friction is subtracted, we were left with the net muzzle velocity rating of 3,000 feet per second. So we need a gunpowder charge that will actually harness 3,400 feet per second, which then compensates for the friction loss as the bullet is cut through the lance and grooves of the bore. It's going to slow down by X amount of FPS and be left with 3,000 feet per second. Now, the question of aerodynamic drag, it's very negligible. There's about a 1.02% loss due to aerodynamic drag. So if we divide that by 100, that is 0.0102 times the applied force. So it's very negligible. So we'll just write NA there. Next, we convert the gross muzzle velocity into its meters per second value. So kinetic energy is equal to potential energy in a closed system. We cannot create or destroy energy. We can only change it in form. So that is relevant to the first law of thermodynamics, the conservation of energy. So this time we're going to calculate the kinetic energy, including the friction loss, and that will equal the potential energy of the smokeless gunpowder charge. So this comes to 1914.83 joules of smokeless gunpowder potential energy per round as a requirement. So we can then divide the 1914.83 joules into the 3504 joules per gram potential energy of smokeless gunpowder. So we actually need a smokeless gunpowder charge equal to 0.5465 grams. Next, we can convert that into grains. So we have to first convert the grams into milligrams. So we multiply that value times 1,000, and then we divide it into the number of milligrams per grain, 64.8. So we calculate a smokeless gunpowder charge of 8.43 grains. Gunpowder charge per round for the AR-15. 223, accelerating a 55 grade round through a 16-inch barrel. So then the last calculation for the AR-15 is to calculate the bullet gravity drop per 100 feet of bullet range. So that's as if you're testing it on a target that's 100 feet away. So we can use the delta D sub y is equal to 1/2 GT squared equation. So this will calculate the free fall time with respect to the gravity drop. So we can take 0.5 times gravitational acceleration on Earth, 9.81 meters per second squared, but then we can multiply it times the ratio of 100 feet divided into 3,000 feet per second to get the time. So then the value cancels out into seconds. So seconds are relevant to both the US and the metric system, and that ratio is squared. So then we calculate the meters drop, for which we then convert into feet by multiplying it times 3.28 and then times 12. So this is a 0.21 inch bullet gravity drop per 100 feet for the AR-15, 0.21 inches. So using the same methodology, we can calculate the same set of metrics for the AK-47, having a 7.62 millimeter diameter caliber, 123 grains round, 2350 feet per second muzzle velocity, and a 16.3 inch barrel. So we have to convert the 7.62 millimeters into the inches caliber. So we divide 7.62 into 25.4 millimeters per inch. There's an extra 4 typo. I actually didn't include that. So 25.4 millimeters per inch. And this then calculates the 0.30 inches or 30 caliber. Convert the bullet mass. 123 grains calculates to this kilograms value. And then the barrel length in inches is converted to meters. So 0.41 meter barrel length. So we'll now calculate the firing time, the barrel length D, divided into the muzzle velocity V. So now we have the firing time for the AK-47. So we can then calculate the force accelerating the AK-47 round. But first we need to calculate the acceleration value for the AK-47's 123 grain round. So this is acceleration, which is equal to velocity divided into time. So that's the muzzle velocity in meters per second converted from 2350 feet per second divided into the firing time T. So we calculate an acceleration of 1,252,622 meters per second squared for the AK-47. And so now we can calculate the force accelerating the AK-47 round, which is the kilograms mass of the bullet times its acceleration in meters per second squared. So this comes to 9984 newtons of force accelerating the AK-47 bullet. We can then divide that value into 4.45 newtons of force per 1 pound of force. And then we get 2244 pounds of force accelerating the AK-47 round. Now we can calculate the ballistic power for the AK-47. So again, it's the 9984 newtons force, which is equal to the 2244 pounds force, times the barrel length in meters. So we have Newton meters. 1 Newton meter is a joule, and then 1 joule per second is a watt. So when we divide the FD over T, in this case, we get a ballistic power of 7,156,364, which is approximately 7.2 megawatts. So we write that in on the right side here. Next, we can calculate the kinetic energy value for the AK-47, in this case the 123 grain round. So 1/2 mass times velocity squared. We get 2046 joules, for which we divide into 1.36, the number of joules to a foot-pound. So the kinetic energy for the AK-47 is 1504 foot-pounds. Next, we do the bullet impact pressure in PSI. So we divide the diameter of the round in inches to get radius. Then we square that value. And then we multiply it times pi to get the cross-sectional area of the round. So the impact force is equal to the force accelerating the bullet divided into the cross-sectional area. So we use 2244 pounds force divided into the cross-sectional area for the AK-47 7.62 millimeter round, which is 0.070 square inches. So this will calculate to 31,740 psi of bullet impact pressure. Next, we calculate the smokeless gunpowder charge, so 16.3 inch barrel times a 25 feet per second loss per inch of barrel length plus the rated muzzle velocity. So we actually need a gunpowder charge for what would be equivalent to 2757.5 feet per second for the AK-47. Divide that value into 3.28 to get its meters per second value, and then we take that V, meters per second value, and square it, and then we multiply it times the bullet mass, then times 0.5. And so then we need an equivalent potential energy of smokeless gunpowder equal to 2816.64 joules. We divide it into 3504 joules per gram potential energy of smokeless gunpowder. So each AK-47 cartridge casing would require 0.804 grams, which then converts into 804 milligrams, then divided into 64.8 milligrams to a grain. So that's 12.41 grains smokeless gunpowder charge per round for the AK-47. And then lastly, we have the drop per 100 feet. So 1/2 GT squared, so we take 100 over 2350, 100 feet, target distance divided into 2350 feet per second. The units cancel out into seconds, so that's T squared, seconds squared, times 9.81 times 0.5. So we calculate a meters drop per every 100 feet of 0.0089 meters. We convert that to feet by multiplying it times 3.28, and then we convert that value into inches by multiplying it times 12. So the AK-47 will have a pretty steep drop of 0.35 inches per 100 feet. That's with a 123 grain round. So before we place the final conclusion specifications, there's a few notes to post here. The AK-47 will have 37% more impact force compared to the AR-15. That is bullet impact force compared to the AR-15, 37% more. The AK-47 will have over the AR-15. Second note, the AK-47 will have 7% more ballistic power compared to the AR-15. the AK-47 will have 37% more kinetic energy compared to the AR-15. Next note, the AR-15 will have 32% more impact penetrative pressure compared to the AR-15. The AR-15 will have 32% more impact penetrative pressure compared to the AK-47 is what I meant. Next, we have the AK-47 will have 47% more smokeless powder consumption compared to the AR-15 per shell. And then lastly, the AK-47 will have 67% more bullet gravity drop compared to the AR-15. So we finalized this analysis conclusions, and we have a clean list here, and this then simply translates to the following pros and cons, is that we have an equal number of pros and cons across both the AR-15 and AK-47. Thank you for watching this presentation, and have a great day.